Good morning, everybody. Welcome to class this morning. We're going to be continuing off where we left off last week, talking about Excel. Last week we were talking about the history of spreadsheets, how we got from the beginning of spreadsheets, the use of spreadsheets in paper worksheets, on into the very first digital spreadsheet by way of VisiCalc. Which is what we have on the screen now, into what we know now today with Excel and other versions of spreadsheets like Google Sheets, OpenOffice, basically every spreadsheet that you can utilize out there today. But before we get started in that, just a couple quick announcements. Just remember that we are working on the assignments in Module 9. They'll be due on Sunday by 11:59 p.m. Please try to make sure you have those finished by that time. Also remember that if you encounter any technical issues with them, please contact Paradigm to try to get those technical issues resolved, and also let me know what they tell you and what your experience was like with them. Again, this is the first time we're using this company for the material for this class. And we are, evaluating it and trying to see how good it works, and, whether or not we'll use it again in the future is in the air, so if you all are finding it well, then it'll continue to be used. If you all are having too much trouble with it, then we might be looking for other alternatives. So it's actually you all and what you encounter and the things that you do that will contribute to what other students use and learn with in the future. So please help us out with that and letting us know your experiences and what the publisher tells you when you reach out to them for assistance. But we are talking about spreadsheets some more. This week we are delving a little more into the concept of spreadsheets. We got to the idea of digital spreadsheets last week, and we ended up right here, what you're looking at on screen now, this screenshot or this photograph of VisiCalc, the very first digital spreadsheet. We said this was taken, we have the date in the lower corner of the picture here, January the 4th, 1979. Right there. So a 41-year-old photo, almost 42-year-old photo. Of a spreadsheet. And we see that, this spreadsheet here is not a whole lot different from the spreadsheets that we utilize today, whether they're Excel, Google Sheets, or what have you. And so what we'll be talking about today will be a little more specific to the digital spreadsheet and utilizing the digital spreadsheet, but it will be generic. It won't be specific to Excel, although there will be some things that are kind of specific to Excel. However, there'll be concepts related to the spreadsheet and how we use spreadsheets. So, one of the things that we talked about last week was we talked about the idea of how the creators of the digital spreadsheet, Bricklin and Frankston, came up with this structure for having our rows and columns for the cell, having the letters across the top and having the numbers down the side. And it was just to give it some kind of structure so that we could reference these cells in a particular manner. And that's the way that we do engage in referencing our cells. So in most electronic spreadsheets that you encounter, the columns are indexed by letters and the rows are indexed by numbers. And it's been that way since the very beginning. And a cell is identified and referenced in writing by its column letter first, followed by its row number. So we're going to highlight a cell for you here. That cell that I just highlighted in purple for you there is cell D3. Because first we go over and we find column D. We go down from there. And then we find the row that it's on, which is row 3. And go over from there, and that references that particular cell, cell D3. And it, like we talked about last week, it, goes back to the old way that maps used to be referenced. And I know, especially the younger among you probably have never used an old school style paper map. But it's similar to the way that, the old school style paper maps are kind of sectioned out with different sections of the map to where you can kind of get yourself indexed on where you are based on the area in the map, its location across the top and bottom. It'll have indices, letters, numbers, that sort of thing for orientation purposes. And we do the same thing here in our digital spreadsheets. And so this gives each of our cells a unique identifier. And that was the intention from the beginning by Dan Bricklin, the inventor of VisiCalc. He wanted to give each cell a unique identifier so he could refer to it as sort of a variable name, this container in which we could put data and reference it later on in equations and things of that nature. So since we're able to reference these cells by their relative positions based on column and row identifiers, each cell on a spreadsheet has a completely unique name. And that's something that you might have done. You might have done that a lot. But what's something that you might not have done quite as much is referencing an entire group of cells. And when we want to refer to a block of contiguous cells, we do that by specifying a starting cell and an ending cell. And then we can separate those cells by a colon to denote that entire region. So I'm going to pull up a region for you here, and this, we're going to highlight it in purple. And so that region there represents cells C2 colon E4. And so C2 would then be our starting cell, all the way to E4, which is our ending cell. And so we can see that represented here. And so that's if we want one big contiguous block of cells. That's what we have going on here. Now, if we want non-contiguous blocks of cells, like if we want this one big block of cells plus another littler block of cells, we can just add other blocks of cells to our reference with commas. So non-contiguous blocks of cells can be referenced using a list in which the references are separated by commas. So what we have already is our C2E4, but we could also add A1 to A3 here. And I forgot a couple little things here, so let's click through a couple times. There's our C. There's our 2. There's our E. There's our 4. Now we'll bring up our A1 to A3. So this segment that we have highlighted in purple now is what we have referenced in our cell here. C2, E4, A1, A3. Represents the segment of our cells that we have identified in purple at this point in time. Now, in programming, we would call this a variable. One of the things that I do here at the college primarily is I teach the programming classes. I teach a lot of the programming classes here at the college. And what's common in programming is something called a variable. And a variable is a container in which we put information. We can kind of think about it in that way. And we give this container a name. And in programming, we can name it whatever we want. And as we put data into there, we can reference it by the name that we give it wherever we want to reference that data. And then later on, if we need to or if we want to, we can change that data that's inside of that cell or inside of that container without changing the name of the container. And so the cells here work in pretty much exactly the same way as a variable in programming in that sort of way. And one of the things that we're going to see here today as we kind of progress through talking about spreadsheets in different sorts of ways is that really what you're doing, and you didn't even know it, as you utilize a spreadsheet, is you're doing some really low-level programming. So when you have something in one of these referenced locations, what happens when it changes? Because really what this cell is it's just a container with a specific name that's given to it by its location via the column and the row. And so it's just a container, and we can put in that container whatever value that we want. So what happens when that value changes? Well, all cell functions that use that cell's value are automatically recalculated. Because when we're doing these calculations, we're not using the specific number that's in that cell. We're using a reference to the value that's in that cell via the name of that cell. So if I have a cell that's, C2, and it has the value of 12 in it, and in another cell I'm doing a calculation of C2 plus D8, it's not 12 plus D8, it's the value of C2 plus D8. And so it goes back to that cell and grabs whatever value is currently in that cell and brings it back. And so this is incredibly, incredibly useful. This goes and it turns on its ear all that stuff we talked about last week that were problematic with paper worksheets. Because when you're using a paper worksheet, you don't have any of those symbolic references. You don't have any of those symbolic links. You have static calculations. So if on paper I write 12 plus 8 and get 20, and then do 20 plus 7 and get 27, and then do 27 plus 13 and get 40, and then all of a sudden realize that, oops, that 12 that I had back at the beginning wasn't supposed to be 12, it was supposed to be 16. Then I can't just go back and change that 12 to a 16 and let everything cascade, because all of those other numbers were static numbers. They weren't references to other symbolic numbers because it's written on paper. It's hard-coded. It's, it's common sense in this case. But when things are digital, we can use these symbolic links to the cell reference names to help us out. And that's what's incredibly useful here. So what's this good for? What's a spreadsheet good for? These are things that you've probably used spreadsheets for before. And we've talked about the purpose of spreadsheets being primarily for calculations and doing math and helping us out with, stuff that's hard for us. So when it comes to what a spreadsheet is good for, there's a lot of stuff in business that spreadsheets are good for. Professional budgets and budget scenarios. You're doing payroll and profit and loss situations, income statements, balance sheets, investment analyses. When we're talking about business, there's all sorts of business applications for spreadsheets out there. And you can find templates for all of these different types of spreadsheets that are existing in the world. You just go download them and bring them into your business. But they're also good for personal stuff in ways that you might not have considered before. Things like working on your personal budget. Like we don't balance checkbooks really as much anymore because of online banking. Online banking nowadays keeps up with our cash flow in and out for us. So we don't have to necessarily do it manually like the example was doing from the old VisiCalc picture. But keeping a budget and keeping, kind of making sure that you're spending the right amount in different parts of your life every month, in case you're like saving for a certain specific thing, can be done with Excel. And I actually have a good video that I might share with you all where I've demonstrated how to create a slide or a spreadsheet to that end. Working with your grades and doing grade analyses, what if analyses on your grades. Keeping up with your grades as you get them. Like, Blackboard does a pretty good job of keeping up with the grades that you got. But I know, everybody as students always has that thought, at some point, like, okay, like I got this in my course currently. What do I need to make on the final to get an A? Or what do I need to make on the final to get a B? And you can use a spreadsheet to kind of do these different what-if analyses and to run different projections based on the different types of grades that you could possibly get. I mean, really, you could keep track of nearly anything with your spreadsheets here. So I mentioned that using a spreadsheet is kind of a lot like programming, and that really, as somebody who uses a spreadsheet, you might be a programmer and you didn't even know it. So let's talk about how you are programming in Excel and you don't even know it. And we can start by talking about the formulas in Excel. You see, Excel uses a very simple programming language. When we talk about programming and we talk about the different things that programming has, we can set up data structures and look at logic and examine a few different things. And every programming language has a few different things. One is variables. Data structures like conditionals, which are like if statements, things that I can use to make decisions, whether one thing happens or another thing happens, which those are present in Excel. Functions, which there are predefined functions within Excel. We'll talk about those in just a minute. And operators. And there are operators within Excel. And operators are just, there are different types of operators. There are comparative operators, things like greater than, less than, equal to. And then there are mathematical operators, plus, minus, multiply, divide. And so really what we're doing here is we're just writing a very simple mathematical program in each of these little cells. So we just use this kind of basic operation here in each of our cells. And we can use these special symbols and we can create little programs. And we even use functions within Excel. Now in Excel we don't write our own functions. We have some predefined functions that we use, but you might be familiar with some of these. Now, in programming, a function is a defined set of instructions, an instruction being a line of code that does a certain thing, that does a function. So in this instance, we have all these operations that are available to us as functions. So things like sum. We have the sum function. So we can write sum, S-U-M, and then put in a range of cells, and it will add all of our cells together for us. It will produce the sum of the cells. So instead of writing, in this instance, we have the sum of cells A1 through A5, B7, C8 through C10. Now we could write that as simply equals A1 plus A2 plus A3 plus A4 plus A5 plus B7 plus C8 plus C9 plus C10. Or we could write it in our function notation as we've demonstrated here via this sum function. And this is a lot easier. It takes a lot less time. And we get the same answer produced to us. And we have a whole lot of other functions within Excel that does a whole lot of math for us. Like that sum gives us the additive sum of all values. But we also have product, multiplication, multiplies all the values together. Max, you want to find the highest number in a list of numbers? Use max to find the maximum value. Min finds the minimum value. Average. Just entering the average function and entering in a range of cells will automatically find the average for you of the numbers in those cells. Count will count the number of cells that have some kind of numerical data in them. Count, which stands for count alphanumeric, will count the number of non-empty cells that have any kind of data in them. And here we have a conditional, an if condition. So we use our conditional operators with this. So if we have two cells and we say if the value of A6 is greater than the value of B1, then we use formula A, whatever that formula might be. In this case, it's just kind of a stand-in. But if it's not, we can use variable B, formula B. It's kind of a stand-in. And this is really all fairly simple syntax for these formulas. And when we say syntax, all we're talking about is how it's written. It's written the exact same way every single time. Like everything that's kind of written down has a syntax. Like English language has a syntax. You capital letter at the beginning, some kind of punctuation at the end, commas go in specific places, that sort of thing. This has a syntax as well. You have your function name at the beginning, a pair of parentheses, and then the rules or attributes for that function go inside of those parentheses. Now this does use our PEMDAS rules. Parentheses, exponents, multiplication, division, addition, subtraction. These mathematical precedence rules apply. So if there's something that you want to do first, you wrap it in parentheses to make sure that that thing is done before anything else. Really simple concepts, right? And like I'm sure you've all used Excel before, or some kind of spreadsheet before. I'm sure these concepts are not brand new to you. And so really, as we kind of wrap things up here, one of the things that we can kind of get into is the idea that these formulas can depend on other cells. So using a function is not just using a function. We can use a function to get the results of another function and then use that in another function. we can take all of this stuff and build upon it. And this is where we get into the real power of a spreadsheet, is in using these symbolic references to the cells and building upon each of the calculations, so that as we make new calculations, we can change one value, and the change of that one value would have a ripple effect going all the way through our spreadsheet, because we've made smart moves in the way that we set up our spreadsheet in determining where we put cell references and how we do different calculations. It's a really, really smart thing. So really what we end up doing is we're creating a little computer program that lives in each cell. A little computer program that lives inside of each cell. And here this whole time, you've been using a spreadsheet, you've been using Excel, you've been using Google Sheets, you've been using OpenOffice, LibreOffice, whatever you use. And whether you've been using it to its fullest capacity or not, you've been a programmer, and you didn't even know it. A prolific one at that, because each little cell where you write one of these functions, where you write one of these formulas, especially when you are nesting them deeper and deeper and deeper, becomes a program unto itself. And that's where the true power of these spreadsheets lie. And so that's all that we're reaching the end of our time here, so that's where I'll stop here for this live stream. That's all that I have for you. Remember again that your assignments for Module 9 are due by 11:59 p.m. on Sunday, so please make sure you have them completed by that time. If you're having technical issues, please try to contact Paradigm to try to get them to help you out there. We want to try to get these things resolved if you're having these technical issues. If you have any other questions, or if you have any issues with any of the material in the book, or any of the material in the Blackboard rather, or if you've dealt with Paradigm and you got some resolution to an issue, any of that stuff, just please let me know. I want to know. Keep me in the loop. That's all that I have for you for today. I'm going to hang out in the chat for just a couple minutes, and just in case any of the people who are live with me today have any questions. And if any of you watching recorded have any questions, please feel free to email. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.